Hey guys, so we're going to get going on lesson 11 to day number 3 today, talking about geometric probability. Not yesterday, on Friday we talked about theoretical probability, and I'm actually jumping over day number 2 because I'd rather be here when we do experimental probability. Geometric probability is what we're going to cover in today's notes. There's a few formulas that you have to remember from your geometry class, so think back to whoever you had last year for geometry. And I'm not going to refresh your memory on all of them, but the ones that come up kind of the most often for us are going to be the area of a circle. So if you could go ahead and sketch in a circle for me, and we're going to draw in the radius as well. Radius is halfway across the circle. And for the formula for an area is all the space inside of there. The area formula is pi times the radius of the circle squared. So A equals pi r squared. You also have to remember how to get the area of a rectangle. So I'm also going to draw a rectangle on here. And most of you guys know that to find the area of a rectangle, you just multiply the sides together. The sides are called the height and the base. And so the formula for a rectangle is base times height. And then the last one that I'll remind you guys of, just because it comes up so often, is a triangle. So go ahead and draw in a triangle. And with triangles, they also have a base and a height. The base is here. The height is straight up from the base. It forms a 90-degree angle with it. That's where the height is. And the formula for triangles is 1/2 times the base number times that height number. Those are the three that are going to come up the most often today, whether it's in your notes or in your homework today. So we just have a few examples to get through, and then you'll be able to have the rest of the class time to work on your homework. So if you take a look at practice problem number 1, it says 3 semicircles with diameters, diameter means all the way across the circle, are 2 centimeters, 4 centimeters, and 6 centimeters are arranged as shown in this figure. If a point inside the figure is chosen at random, what is the probability that the point is inside the shaded region? So if you think about this, probability, whether you're talking about theoretical probability, geometric probability like we are today, or experimental probability like we're going to talk about tomorrow, probability is always the part that you care about divided by the whole entire thing. And if you look for us, we care about the shaded part right here. And obviously, if you look at that shape, we don't have a name for that shape because it's kind of an awkward area, but it is made from a bunch of circles. So the part that we care about is shaded. The whole entire shape is 1/2 of a circle. So we can definitely use our circle formula to figure this out. So we've got the big entire circle. I'm going to do that first. I'm going to call this the big circle. And for the big circle, we're going to use the formula for any circle, which is pi r squared. And if you look at all the way across the big circle, the diameter is 6 centimeters. That means that halfway across of that would be the radius, which is 3 centimeters. So I'm going to do pi times 3 squared for that one. When you type pi times 3 squared in your calculator, you should get, it's a big long decimal, but if you round it, you should get 28.3. Now that formula is for an entire circle, so that means if this circle went all the way around, the area of that, all the space inside, would be 28.3. But we don't have an entire circle, we only have 1/2 of one. So I'm going to take that 28.3 that I got in my calculator and divide it by 2. When you type 28.3 divided by 2 in, you should get about 14.1. So that's for the big one. That's our total number, that's our whole number. All right, now I'm going to switch and take a look at the medium circle as well, because the shaded part is not the big circle. The shaded part is the circle taking out the medium circle and the small circle. So if I look at just the medium circle right now, it's still a circle. We still use pi times radius squared, but the radius of this medium one, halfway across here, would be 2 centimeters. So in my calculator, I'm going to end up doing pi times 2 squared. When you type pi times 2 squared in, you should get about 12.6. But again, that would be if that medium circle was an entire circle. It's definitely not, it's 1/2. So I'm going to cut that in 1/2 by dividing it by 2. When I type in 12.6 divided by 2, you should get about 6.3 there. The last part of this is the small circle. And I'm going to do the same exact thing for the small circle as well. If I look at the small circle, halfway across there would be 1 centimeter. So I still use my circle formula, pi times radius squared. I'm going to plug in 1 for the radius. Pi times 1 squared is, you should get about 3.14. But again, that would be if that small circle was an entire circle, and it's not, it's half. So divide that in half, divide by 2, and you should get about 1.57. So now that I've got all of my areas figured out, I want to figure out what the shaded part of this is. So if I go back here, the shaded part would be the entire thing, but take out the medium and the small circle because they're not shaded, they're white right now. So to figure out the shaded part of this, I'm going to label this as shaded. I would have to take my big area that I got, the 14.1, and take away, that means subtract in math, these medium and small areas that I found. So I'm going to have to minus the 6.3 and the 1.57 from the medium and the small circle. When I do that, my shaded part gives me, it should be about 6.23. Okay, so that's the part that we care about because the question said what's the probability that the point is in the shaded region. That's what we wanted. So if I come back up here to my part over whole equation, I can plug in that 6.23 number that I just got. That's the part we care about, the shaded part. The whole thing was this big half circle. The big half circle we figured out was 14.1. When you type 6.23 divided by 14.1 in your calculator, you should get about 0.44. And you can scooch that decimal over and call that 44% if you'd like. That means that 44% of this circle is shaded, or I would have a 44% chance of picking a point in the shaded area versus the white areas of it. So lots of formulas, lots of work, but not difficult work. All things that you guys are very familiar with. Okay. If you take a look at problem 2, problem 2 says find the probability that a point chosen at random is inside the shaded area again. So again, guys, we're working on probability. Probability is always the part that you care about out of the whole thing. The part that we care about happens to be shaded again, but if you look at the shaded part this time, the shaded part is almost like a frame. Well, nobody has a frame formula, but if you look, the two shapes that are made up of this entire thing are two rectangles. So if I look at the big rectangle separately, just like I looked at the big circle earlier, the big rectangle, I would have to do my base of it times my height of it. So that would be the 16 and the 8 right here. 16 times 8, if you type that in your calculator, is 128. And then I can look at the smaller rectangle as well, the white one in here. If I look at the small rectangle, the side lengths or the base and the height of that are the 5 and the 14 right here. So I would type 5 times 14 in my calculator, which would give me 70. Now, with the big rectangle and the small rectangle, the way that I get the shaded part is by taking this big one, but taking out the small one. Taking out in math means subtract. So I've got to do 128 minus the 170 right here. When I do 128 minus 70, that gives me a shaded portion of 58. So the shaded part is 58. All right, that's the part that I care about. So I can come back up here and say the part that we care about, we just figured out is 58. Out of the whole thing is this big whole rectangle, which we figured out already was 128. When you type 58 divided by 128 in your calculator, you should get about 0.45, or if you turn that into a percent, that would be about 45%, which means you have about a 45% chance of picking a point in the shaded area versus any of that white space inside of there. All right, last one, guys. Number 3 is a little bit different because instead of being a shape, it's a straight line, which actually makes it a little bit easier. It says, find the probability that a point chosen at random will be between B and C. So again, guys, they're asking for a probability. Just like the other ones, that still means the part that we care about out of the whole thing. Now, the part that we care about that they asked about was that space between B and C. So if I look just between point B and C, in my picture, point B and C would be right here. Well, if this is at the number 8 and this is at 12, the space between there, I would just have to do 12 minus 8 to figure out how much space is between there, and that would be an amount of 4. So 4 is how much space is between B and C. That's the part that I care about. Out of, then I have to do the whole thing. Well, the whole thing would be this entire line segment from A to D. A starts at 4 and D goes through 24. So if I want to figure out how much space is between 4 and 24, I just need to do 24 minus 4, which is an amount of 20. So I would write a bottom number of 20 since that's the entire thing. If you type 4 divided by 20 in your calculator, you should get about 0.2. If you move your decimal over twice, that would equal 20% there. So your answer for number 3 would be 20%. You'd have a 20% chance of randomly picking a point between B and C versus any of the other space on that line segment. So that's what you guys are working on today. Go ahead and get started on your homework. Make sure that you are showing your work on the homework because, as you can see, there's a lot of work that goes into figuring out all of these answers. I will look for work when I come around to give a grade tomorrow when I see you guys. I hope you guys have a great rest of the day, and I will see you tomorrow.